This tutorial explains how to 3D model and edit a part that will help prepare you for the Certified SolidWorks Associate Exam. This video is separated into two parts. Part 1. To create this model, I've downloaded pre-existing part files from the SolidWorks CSWA website under the Sample Exam option. Using these parts, I'll be creating an assembly file. All CSWA exams have assembly-based questions where you have to accurately calculate mass property information. In the menu to the left, you can see the 3 part files I have open. I've selected the pin at the top so that the menu stays in place while I bring in all of the parts that I need for this model. I intentionally selected the long pin first because I want that pin to be fixed in place, because later in the video I'll be setting up a coordinate system on that pin. Now that I've inserted all of the parts needed for this assembly, I'm selecting the green check mark to OK that I'm done with that menu. Next, I'm double checking to ensure that the green pin that I put down first is fixed in place and not floating. Before I begin mating these parts, I'm moving each part individually closer to the part that it will mate with, just trying to get it into position so that when I do mate the parts together, they move together seamlessly. Since I want the chain link part to move about the pin, I'm going to create a concentric mate. Next, I'm creating a coincident mate where I'm mating the top of the chain link face to the top face of the pin. Since I don't need the smaller pin to rotate within the chain link, I'm going to create a coincident mate between the edge of the short pin and the edge of the chain link. While I continue mating these parts, I need to ensure that the chain link parts are concentrically mated with the short pin, allowing the chain link to freely rotate. I'll also continue to mate the exterior face of the inset chain link to the interior face of the outset chain link to properly align and secure both parts in place. Now that I have all of the parts properly mated, I'm going to create a coordinate system to assist with calculating the model's center of mass. To begin this, I'm selecting reference geometry and then a point and placing that point in the center of the top face of the first pin that I have fixed in place. Next, I have selected reference geometry coordinate system to create the actual coordinates that I want to use for calculating the center of mass. So with this, I have selected the point in the beginning box, and then I select lines that go in the direction of the X, Y, and Z axes. And you can see that in the top right image of the assembly that I'm working to create. I've had to flip the Y and the Z to be able to get the axes to go in the proper direction. I have the coordinate system set up, but when I click away, the symbols disappear, but I can still see both the point and the coordinate system listed over in the Feature Manager. Next, I'm creating mates that will set the angles so that I can calculate the center of mass. I've selected the angle mate option or button and typed in 25 degrees for that mate. Then I selected the two lines that will be set at 25 degrees. And chaos has ensued, so now I'm going to select a few mate flip and mate alignment options to be able to get that assembly into the correct formation according to the picture in the top right that I'm working from. Here again, I'm selecting the angle mate option and then selecting the two lines that are next that will be set at 125 degrees. I'm also having to reselect different mate alignment and mate flip options to get the assembly to orient in the correct direction. Now that I have the assembly complete and it looks very similar to what's in the image in the top right, I'm going to evaluate mass properties, and I need to set the coordinate system not to the default, but to the coordinate system that I created. And this will give me my center of mass calculation. This concludes part 1. Part 2. In this part of the tutorial, I'm just going through and editing the mates, specifically the angle mates that I created. I'm updating the degree of angle as it relates to the image in the top right. As with the other questions in the CSWA exams, they often ask you to create an assembly or a part file, and then the second question to that problem typically is to go back and edit the dimensions, or in this case, degree of angle, to a different number so that it will update and create a new center of mass. Now that I have all of the angles edited, I'm going to evaluate mass properties, making sure the coordinate system that I created is selected, and just seeing what the center of mass is that would answer one of these type questions. This concludes part 2 and is the end of the tutorial.